Hello and welcome back. Usually on this stream we do Automat live coding. Not today though. Today and during the last stream as well, we've been working on this black hole shader. The point of this shader is to actually be part of Automat though, so kind of we are coding Automat. So what this is, if we open Automat, the main way within Automat to discard objects you don't need is to throw them out in this trash area in the corner. And this trash area, we would like to, instead of having this simply as a gray flat section of a circle, we would like to shade it in some interesting way. And a decent metaphor for this area here would be something that destroys whatever you throw there, but in some sense it keeps it around, because ideally we would like to have the ability to do undo operation or like pick objects outside from this trash. And it seems like black holes would be a very nice fit for this place in the interface. So when we don't need an object, we throw it in the black hole, but we also have the ability to extract them. Because, you know, as long as the object doesn't enter the horizon, it kind of travels in time. One more thing that we need to figure out is to how to reconcile this black hole that would exist here with two other ways of deleting objects. One of them is through this option, this delete option. Right now they just disappear. Same here. When I release it, it immediately disappears. So when I delete the object instantly, it should disappear in some more interesting way. And I guess this could be by being sucked in this way into the closest black hole. Or maybe a black hole could appear and like below it and suck it out. The second thing that we should figure out how to make it work is this black section around the canvas. So when you work with Automat, you have this 1 by 1 meter canvas to work on. And throwing an object out is another way to delete it. So this section outside of the canvas, it should also kind of look like a black hole, ideally. And it needs to blend smoothly with this circle here. It's not going to be very easy. Anyway, I think we will figure this out. I mean, we did figure out a proper way to do this. It's maybe not ideal. So the shadow of the object is being sucked in a rather strange way. So this corner here, I would like to... I wonder... Okay, so this is probably because the SDF that I used, this SDF could probably be improved. This sharp corner, this is a mathematical artifact. I think we will be able to eliminate it if we define this shape differently. Should be doable. Now, as long as the object is inside the canvas, I don't think it should be sucked. Only when it's on the black hole. This is where the sucking animation should start. Okay, so this is Automat. This is how we want to use the black holes. Now let's switch to this place here. Specifically, during the last live stream, I found a couple of shaders that have a very cool effects, like this one. This one has a really nice Accreation disk effect. It's very cartoonish and very clean. Like when you look at it, you immediately see, hey, this is a black hole. Another one, which is more of heavy metal, is this one. This is interesting because it creates this sensation, this effect of continuous pulling in. It's a really nice effect. I want to see how it's done, and there are probably a couple of places within Automat where we could use this sucking effect. And we have one more. The last one is this. I like this one because it creates a really nice spiral. If you leave it running for too long, the spiral gets very boring. It just starts looking like a circle. So shouldn't probably just make it verbatim. We should probably tweak it a little bit so that it looks nicer. But I have this piece of code here. I can refactor it now a little bit so that it could allow a more modular choice of the Accreation disk effect. So let's do that. So here we are coloring the canvas. Yeah. Okay, so we will have a new function called it's really just shader. It's going to return a color based on the distance from the event horizon. The event horizon is this rectangular shape with a cutout that we have here. So I have this scaling which makes this boundary more flatter. If I disable this, this is how it looks like. Okay, we also have this radius. Let's put it here as a global. Will this work? Not yet. Okay, I need a better... Okay, so I am using UV also here. Okay, we have the same effect now. But now we can easily swap the Accreation disk function to get different coloring effects. So let's call this Accreation disk 1. And actually there is something I wanted to change.
CP Chica says.
Another 5-hour-long shader coding session.
Not this time. This one is actually going to be super short. And this is because I am taking my dog to the dog doctor. Okay, I messed up. Suppose let's just do UV. Looks better. And I should divide by just 1.
Why dog doctor is not called doctor.
Should be. With proper capitalization, like dog.
And why is he my title doctor and not Dogtor?
Okay, new accreation disk effect. Let's look at like this one. This one has the shortest math.
Wantonity8 says.
Welcome back.
DP Chica says.
Speaking of titles, from today, people in Germany are legally required to address me with Magister.
Oh, congrats. Nice. September. Is September typically the time where academic year ends? Or is it just a German schedule?
Wantonity8 says.
You were busy or you just took a break?
Regular vacation. Taking a break from non-stop coding.
DP Chica says.
I had to switch universities, so I had to wait a bit before defending magisterium work, but by Bologna it's usually July around 15th most of the time.
Yeah. Well, congrats again. You've been working on some embedded systems, do I remember correctly? Embedded, distributed something.
Wantonity8 says.
From the All AI and Cybermasters programs, I took totally different option. I enrolled to cloud computing. I hope it's not bad decision.
Yeah. It's definitely popular right now. About cloud computing, I always had this.
CP Chica says.
Implementation of Minix for distributed embedded system.
So I had the pleasure of working with cloud for some time. It's like, but not this cloud that you can typically see in like Amazon or Google Cloud. Internally, once you get access to those data centers, running jobs there is actually much simpler. Like you literally write a program that builds a zip file that's sent to a couple thousand machines and executed there. And it's it's literally a zip file, like. So this is how a big chunk of Google Cloud works, Borg. And it's fun to program on. It's like literally a different type of computer. But the interesting thing is, most of those things that you would do on a cloud, when you try to translate them and to implement them locally on a single threaded, even CPU, usually it works. It's like, if there is like an axis of complexity of programs that you can build, no, let's say this is the axis of complexity and those programs are very complex. Like, for example, building a state-of-the-art language model, like, would be right here. You need a lot of matrix multiplications to do that. And doing something simple like playing Tetris or Snake is here, and a lot of programs are kind of in between. So on this axis, there is a section of things that can be implemented on a local PC, and it basically ends at some point. And if you use a data center, yellow, on a data center you can kind of reach a little bit more further into the future. On a cell phone, like, or a smartphone, the stuff that you can do is somewhat like here. The thing is, over time, if we do time here, this is how it looks over time.
Why, this sounds like talk between two doctors in field of systems engineering, and they're trying to find middle ground. Distributed means...
So the capabilities of smartphones, they started, I don't know, somewhere here. But over time, they went, now they are here, and in the future they will probably be here. Right now, I think you can even run Witcher, right, on a smartphone. You definitely can run a Witcher on a Switch, so I guess you can run it on a smartphone. So the capabilities of home PCs are somewhere here, the capabilities of data center are here, and they will keep increasing over time. And in this view, data center and cloud computing is like the ability to operate on personal computers 10 years in the future, or smartphones 20 years in the future. Something like that. It's like a telescope. Cloud computing is like a telescope for computer science. Okay.
Yeah, my phone is Data Center from 1990, but it's only useful if it has more than 25 of battery capacity and has signal touch.
Yep. Okay, so the author of this code tried to minify it, which makes it slightly harder to work with.
Wanton98 says,
That's interesting. thank you for the information.
Yeah. Okay, so we will have to adapt those variables. So this A here, this arctangent, we can provide a replacement, SDF-based replacement for arctangent. So what it is, it should basically tell us what the angle of the gradient of the distance function is. So we can define a gradient like that. It's nice that GPUs can differentiate. This is their like secret power. Regular CPUs cannot do this, only GPU can do it. So we have a gradient and yeah, I think this should work. Next we have distance, I think, from you. Yes, from the center. For us, this distance from the center is just dist. Then we also have S. What is S? S is a constant. Those are all constants. Nice. Next we need U. Small u.
CP Chica says,
Just to finish my talk about titles, in Germany they count value their education so much that any academic title you acquire is also your legal title. Unless in formal setting, say courtroom, you don't say that you prefer be addressed by, quote, normal titles. So, sir, ma'am.
Yes. So you are Magister from now on. How do you say master in German? Meister. You are Meister, right? Sounds nice. Meister Chica. Nice ring.
Mr. Eski, Mag Comp Eski. Dr. Math Pillar.
Yeah. Speaking of titles, in Poland, the scientific title and the engineering titles are also a separate thing. So it's not the doctor math, it's doctor engineer math. Engineer is, on one hand side, it's much faster to get than PhD, obviously, right? You can get engineer just after a couple of technical, like years of technical studies. But because they are technical, it's somewhat harder. There are all sorts of humanistic study directions where it's possible to get a doctorate and not be an engineer. My professor always said that the doctor title is the less important of the two. It's more important to be an engineer than to be a doctor.
In Croatia, you would be Dr. Ski, Mag, Comp in Joe.
Yeah, it's getting long. Oh, it has... Oh, this is only used for texture lookup. We don't need this. Oh, but it's also used for this deformation. Okay, let's swap out the function and see what we get. And it's crazy. Looks like there is some spiral going on here.
Continent8 says,
I guess CP Chica is from Croatia, right?
Much warmer and sunnier place than Germany. I mean, right now there is probably not that much of a difference between Croatia and Germany, but in winter it's brutal. Okay.
CP Chica says,
Speaking of lawn, this was my previous title. Une back compiling copy.
Let's decode this. University Bachelor? Computer Science Engineer? And Computer Engineer. Computing Systems Engineer. Yeah. I see that. Okay, we managed to create something that rotates. Kind of. I would like to make it rotate in the opposite direction. Yeah, that works.
I'm using Mr. Ski. From now on, it's just 4 letters.
So here we have just a couple kind of folds. It folds the SDF a little bit to create a black inside. I think we will keep this. Instead we will introduce our own folds. Okay. I want a function. So let's plot a distance. This is this. When a distance is below 0, I want the function to be 0. And then let's also put a number here called L. This is the strength of the Accreation disk.
Was there research made on using RTI in any form in operating systems?
There was a whole idea of object-oriented operating systems. This whole Smalltalk VM is kind of based on LTTI. It's pretty cool. It's so bad. Those Google results. Smooth step, this is what I was going for.
My main idea is that basically, since in OS, you have concept of nodes, same amperage node, in OD4 disks, etc. You could potentially chip away a couple of microseconds using address-based RTE, say
I'm not sure I follow. So in OS you have a bunch of internal data structures, yeah? Those internal data structures rarely use polymorphic. I mean, probably sometimes they do. So you're talking about polymorphic structures within the kernel. And you're thinking about replacing the function pointers, because they are, I guess, based on function pointers, at least in Linux, with types, right? Okay, so this is our first alternate version of black hole.
I don't, poo driver, need to know what kind of knot it received by kernel at runtime until it needs to perform some operation on it. I querying physical address of it. So my idea boils down to do stuff, check type, do specific stuff.
Yeah, I'm not familiar with anything like that. I mean, not in the context of operating systems. Android is kind of fully object-oriented. In Android, you have binder objects that are passed between processes. I'm not going to play with this. I think this is enough. Let's try another shader. This one is completely crazy now. This one... Okay, this one is complex. Okay. Some of the functions. FPM3D. And we'll also need probably all of those. Emission is such a strange function, it's just a multiplication. So normalize it to 1. Okay, maximum normalized component. Okay, this is a little zoomed in version. Now let's give it the shape. Of our black hole. Okay, this doesn't look like an angle. Okay, so this is how the spiral is implemented. So the further we are from the center, the more twisted it becomes. And the twist is defined like that. Okay. I think this color is not really a color. The Z component is like a time. What's in the first two components? So this is pretty much obfuscated code. So this is what we actually keep in the color. I actually wonder, I think the author of this shader used the same methodology as I, which is typing random math formulas until it worked. So I see, for example, that the time is used in the lookup here. Let's save. Just color. This one is nice. Okay, it's enough if we use just one value, and I think 3 of them. Let's see. The distortion doesn't make sense. Distortion just makes it brighter. Yeah. Now it looks like my wallpaper, kind of. The one in the background. I could literally replace my wallpaper with this shader. It's the same thing. Okay, frequency. I guess frequency should be called scale. Because what we're doing, we are looking up simplex noise at this coordinate and adding it here. Shift is always 100. This is just scale. Instead of UV, I'm going to use this. Fortunately, it's not good enough. I also have angle here. Okay, it looks like it's pulling everything towards our rectangle now. It definitely became more rectangular. I think this one is going to be the nicest if we iterate on this. It's very strange. In each channel we have a completely different kind of noise. This one is a regular cloud-like noise. And this one has a more liquid feeling. And that one is like totally liquidy. And this is a combination of all of them, which looks nice. Why does it look like that? In this one I understand. So we are accumulating value. We start with amplitude of half, like simplex noise. This is just accumulating our octaves. Different smaller and smaller octaves of noise. After each octave we are shifting the noise. by multiplying it and adding a shift. Oh, I see. This is because it's passed recursively into itself. So this shift has no meaning whatsoever. Actually, it does change a little bit. We need to shift it probably not to sample. Constantly in the same place. And those look like just random fiddling with color. This is not relevant to us. And this is so strange. Normalization here seems to be key to the sucking animation. Why? Who knows? This is the color before normalization. This color after normalization. Actually, if you think about this color as a vector, when we normalize it, and when it's pointed here, this vector has 0 components. The only component it has is the z component. Which we are using to rotate. I mean, yeah. Okay, I will have to play with this another time. I got to go. This is it for today. We have a couple new versions, the black hole. This one and our original one. Probably the last one looks coolest. I will try to make it somehow work. But to do this, I need to understand why this normalization is necessary here. Anyway, see you next time, on Monday. Bye bye.